Hi students, how are you all? I hope you are all fine and safe at home. This is K. Venkatesan from Department of Physics, Bharathidhasanar Matric Higher Secondary School, Arakkonam. Now I am going to introduce a new topic, electric dipole from 12th standard physics, first unit, electrostatics. See, electric dipole. Now I am going to introduce electric dipole. Before I remember that the electric lines of forces, the basic properties of electric lines of forces. We know that concept, the electric lines of forces is always starting from positive terminal to ending at a negative terminal, which means, see, the electric lines of forces is always positive terminal to negative terminal. This observation conclude that here unlike charges we know that attract with each other. The next one is like charges. We know that concept, like charges, what happening? Positive charge repels with each other. This concept we know that this is the basic properties of electric lines, and also in these electric lines of forces never intersect. The next one is, see, for a positive point charge means the electric lines of forces or electric field lines radially outward. How, sir? See here. This is the positive point charge in this electric lines of forces is always radially outward. This is one of the basic property. Next one is, suppose here negative point charge means this negative point charge. The electric field lines or electric forces is always towards, means radially inwards. The lines of forces or electric field lines radially inward. This is the basic concept. Now I am going to introduce the interesting topic, electric dipole. So what is the meaning of electric dipole? Electric dipole is nothing but two equal and opposite charges separated by a small distance constitute an electric dipole. See here. Two equal and opposite charges separated by a small distance constitute an electric dipole. For example, see, plus Q charge, one type of charge, minus Q charge, another type of charge. In these two charges separated by a small distance 2a, it constitute an electric dipole. Basically, some of the charges or some of the molecules, the charges do not coincide. That means center of charges does not coincide. Such a molecules we are calling dipole. For example, water molecules, H2O, ammonia, HCl, which means hydrochloric acid, etc. These are all good example for electric dipole. Is a basic concept. The next one is example for water molecules. Here positive, negative, positive separated by small distance. Water is a good example for electric dipole. See, for example, another example also. See, HCl, which means hydrochloric acid, H plus ions and Cl minus. Here positive charge, here negative charge separated by a small distance act as a electric dipole. Okay, it's an example for electric dipole. The next one is, see, electric dipole moment. The electric dipole moment is nothing but, see, it is used to measure strength of the electric dipole. Say Electric dipole is another topic. It is used to measure strength of the electric dipole. What's the strength of the electric dipole? Now I will discuss. See, the electric dipole moment is a vector quantity. It is used to study the strength of the electric dipole. Already we know that electric dipole basic concept. Two opposite charges plus q minus q separated by a small distance, it constitutes an electric dipole. Now I am going to discuss dipole means electric dipole moment. See, the basic formula for electric dipole moment, the electric dipole represents letter p vector is one of the charge and distance between the 2 point charges. This is the definition for electric dipole moment. The electric dipole moment perfect definition, the magnitude of one of the charge and the distance between the 2 point charges. This is called electric dipole moment. Okay, see here, the electric dipole moment is nothing but magnitude of the electric dipole moment is the product of the magnitude of either charge, which means one of the charges, and the distance between the 2 point charges. This is called electric dipole moment. This is a basic, this is a very important 3 more questions in your board exam. See, next concept. See, the SI unit of electric charge, Coulomb meter. How, sir? See here, the unit of charge is, we know that unit of charge Coulomb, distance, unit of distance meter. So, unit of electric dipole moment is Coulomb meter. Here answer Coulomb meter. The next one is, that means next heading, electric field intensity due to an electric dipole at a point on axial line. This is very important 5 mark question. See, and very interesting derivation part. See, my dear students, electric field, I am going to determine the value of electric field due to an electric dipole. What is the meaning of electric dipole? Let us consider a 2 point charges plus q and minus q separated by a small distance constitute an electric dipole. In this electric dipole, each charges produces electric field at any point on the axial line. See, let us consider 2 point charges minus q, next one is plus q. This minus q plus q separated by a small distance, which means 2a, this one a, this one a. So, a plus a equal to 2a. Minus q charge plus q charge separated by a distance 2a, it constitutes an electric dipole. So, in this electric dipole, which means electric charges produces electric field at a point C. How much electric field produced at the point C? This one type of charge, plus q. In the plus q charge also produces some electric field at a point C. Here minus q also produces electric field at a point C. So, we need, I am going to find out the value of total electric field at a point C. How much value? These are conclusion. Okay, see, listen here. See, let us consider a point C at a distance, this point C at a distance r from midpoint of the axial line. This is the axial line. See, my dear students, A, B, C, this is the axial line. Suppose equator line means this only equator line, this only axial line. I am going to determine the value of electric field at a point due to an electric dipole and at a point on axial line. That only our question. See, let us consider a point C at a distance r from midpoint to O. Okay, see, now plus q charge produces electric field at a point C is E plus vector, because E plus vector radially outward. This concept we know very well, because here positive charge, the positive charge, the electric field lines always produces radially outward. So, electric field radially outward, E plus vector. Here minus q charge, the electric field produces radially inward, which means E minus vector. Here E plus vector electric field produces due to plus q charge. Here E minus vector, which means electric field produces due to minus q charge. So this conclusion we are going to find out the value of total electric field at a point C. Okay, see, listen here one by one. See, the total electric field at a point C is electric field produces plus q charge E plus, minus q charge E minus. So total electric field equal to E plus vector plus E minus vector. See, listen. The next one is E plus vector is nothing but the electric field produces at a point C due to plus q charge, due to plus q charge. See, my dear students, this is the plus q charge, no? This plus q charge produces electric field E plus vector. This formula you know very well, basic concept. The electric field E plus vector equal to, what is the formula? Electric field is defined as force per unit charge. The final expression E vector equal to 1 by 4 pi epsilon naught q by r minus a whole square. How is r minus a whole square? We need the value, the distance. What is the distance? Plus q to C point. What is the distance? This only total is midpoint to C only r, but we need plus q to C point. So in this value minus r minus a. So here r minus a whole square. This is our formula. Okay. The next one is P cap is nothing but unit vector. The P cap already you know very well. So P is nothing but electric dipole moment vectors. This electric dipole moment is always goes to minus q to plus q. The next one, see, the electric field produces where at a point C due to minus q charges. See, 1 by 4 pi epsilon naught q by r plus a whole square. So we need this distance minus q to C. Here r distance plus a, r plus a is the total distance. So r plus a whole square. This is our formula. So first equation, which means total electric field equal to, according to superposition principle. What is the superposition principle in electric field? E total or electric field total equal to sum of the electric field, E1 plus E2 plus E3 dot 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 En. Here also same concept. The total electric field Et equal to, that means Et nothing but total electric field at a point C equal to sum of the electric field. This one is plus q charge, this one is minus q charge. So E plus vector plus E minus vector. So adding these two equation here, this one equation minus this another one equation. See, the next one is cross multiply this value. Common terms here 1 by 4 pi epsilon naught q cancel, common term takes out. See here q by 4 pi epsilon 0, remaining term 1 by r minus a whole square minus 1 by r plus a whole square. See, into P cap. Here cross multiply these two terms. So total electric field at a point C equal to q by 4 pi epsilon 0, which means epsilon 0 into cross multiply r plus a whole square minus r minus a whole square divided by r square, this multiply minus a square whole square into P cap. Are you clear? What is the formula for r plus a whole square? A plus b whole square equal to a square plus b square plus 2ab. Here r minus a whole square, which means a minus b whole square, a square plus b square minus 2ab. The expression in about equation. So total electric field Et equal to q by 4 pi epsilon naught 0 or epsilon naught into r square plus a square plus 2ra, here minus r square minus, which means plus a square minus 2 RA divided by R square minus A square whole square into P cap. Okay. Minus, you want to multiply this minus, total electric field ET equal to Q by 4 pi epsilon 0 into, what is the value? R square plus A square plus 2RA minus into R square minus into A square minus A square minus into plus, which means minus into minus plus only. So 2RA divided by, what is the value? R square minus A square whole square into P cap, See here, see my dear students, listen carefully. Here plus R square minus R square cancel, plus A square minus A square cancel, remaining 2RA plus 2RA, what is the value? 4RA divided by R square minus A square whole square. Okay. So see, so remaining total electric field at a point C equal to Q by 4 pi epsilon naught into 4RA divided by R square minus A square whole square into P cap. Okay. See, one condition see here, the distance R, you want to compare this distance R is very large compared to this distance, which means A. So here R square is greater than A square. So multiply this value, R into R square, R power 4. Similarly, R power 4 is greater than A power 4. So in this A power 4 we neglected. Compare the distance R. So A value is very less. So A power 4 also neglected. Okay. So substituting this value in above equation, the total electric field at a point C, E total equal to Q by 4 pi epsilon 0 into, what is the value? 4RA divided by, here R power 4 only, R power 4 into P cap. Okay, here R power 4, see, R power 4, R cancel, remaining E total equal to Q by 4 pi epsilon 0 into 4A divided by R cube into P cap. Okay. See here, one basic concept we know that electric dipole moment formula. Same my dear student, what is the formula for electric dipole moment? That is the same concept already we discussed. Electric dipole moment P vector equal to one of the charge into and the distance into P cap. This is the general expression for electric dipole. See here, 4A into Q splitted 2 into 2A. You know that 2 into 2A. See, ET equal to Q by 4 pi epsilon 0 into, see, 2 into 2A divided by R cube into P cap. See, here, see, Q into 2A, already we know that Q into 2A dipole moment. So substituting this value in this equation, we will get the answer. Total electric field ET equal to, what is the value? 2P vector divided by 4 pi epsilon 0 into R cube. So in other words, we are writing total electric field at a point C equal to 1 by 4 pi epsilon 0 into C, 2P vector divided by R cube. This is the very familiar equation. Okay. See, this is the electric field at a point C due to plus Q and minus Q on the axial line. Okay. Finally, we will get the answer ET equal to 2P by 4 pi epsilon naught into R cube. This is the final solution for axial line, electric field due to an electric dipole on the axial line. My dear students, below this video we have attached PPT, YouTube link, study materials in this description. Thank you.